Homework 2.2, more on functions, video 5. Homework due Friday, May 22nd, 2020 at 11:59 p.m. You'll notice obviously that I'm not filming the whiteboard, but rather I'm showing you my laptop screen because I want to share with you a website that is really easy to graph things with. If you have a graphing calculator, that's nice, but this website's pretty awesome. The name of the website is Desmos.com, D-E-S-M-O-S. And by the way, I'm holding my phone instead of using the tripod because this is my second take and the tripod was acting goofy. Hopefully I can fix it before I go back to the board. But if you go to Desmos.com, then you get a graphing calculator website. Now you don't see the graphing calculator, and if you scroll through the website, which I'm about to do, you're gonna see some images, like some nifty math stuff, or even some art things that people have used this graphing calculator to do, because it does have color capabilities. But if you just want to use it to graph, you should click on Start Graphing. And you'll see a graph here with nothing on it because there's no equations over here entered on the left. The nice thing about Desmos is that it's so intuitive, as long as you know a few things like how to type powers. I'm going to start typing the first equation that was in the last video, y equals x squared plus 5, y equals x, and if you notice it's already graphing, because it graphs instantly as long as it can understand what you've typed. Now I'm going to turn off the graph for a second by clicking this button. So the equation will be there, but its graph is hidden. To enter an exponent, the symbol for an exponent is a caret symbol. It's like a little arrow pointing up, and it's above the 6 on a keyboard right here. That symbol is the symbol for exponent. And if you have a TI graphing calculator, that's the symbol. So the reason I'm pointing that out is if you're going to type in exponent in Desmos, you can just hit Shift 6, and when you do that, watch what happens to the cursor. It goes up in the sky where an exponent is. And that little exclamation mark means I don't understand what you've typed so far. You've got an exponent that's missing, so I'm going to type square. And then I believe the rest of the equation had a plus 5. Now be careful. The cursor is still currently up in the exponent, so if I type plus 5 right now, it's going to, oh, wow, this must be smart. I expected it to type the plus 5 up in the exponent, but what I was going to say was if your cursor is in the exponent and you want to remove it, just press the right arrow key right here on my keyboard, and it will move the cursor to the right and subsequently out of the exponent. In some graphing calculators you have to do that, but apparently Desmos is getting smarter and smarter each day. Is there a way to type plus 5 in the exponent? Yeah, you would have to put parentheses around the 2, but I digress. So now we've got that equation, and remember, and I can turn around and you can see it. That first equation we said did not have X-axis symmetry, but did have Y-axis symmetry, but does not have origin symmetry. So when I turn this graph on by clicking this circle to the left of it again, I should expect a graph that has Y-axis symmetry. Now, before I click it, in a previous video, I said the more you know about equations and functions, the less work you have to do about graphing. I know exactly what this graph is going to look like because I know two things. Number one, I know that's a parabola that bottoms out at the origin. In a video in the previous series, I mentioned that towards the end. And I know the effect the plus 5 has on it. As you do some of the homework from section 2.1, homework 2.1, you'll see some questions that ask you what effect does this number have after you've sketched some graphs. But I know that plus 5 is going to move the parabola up 5. So I'm expecting, let me zoom out. When I turn this graph on, I'm expecting a parabola that is 5 spaces above the origin, and there it is. I can't see most of it, but you can click and drag if you're using a computer. On an app, you might be able to just hold and drag with your finger. But we get exactly what we expected, a graph that has Y-axis symmetry. So now you might be thinking, wait, I can get the answer to what type of symmetry does it have just by typing this equation in Desmos. And you're correct, but I still want you to be familiar with the concept. So try to use technology wisely, not to get answers, but to confirm what you think is going to be true. Let's try the next one, which was x equals 3y plus 8. I believe it was. Let me turn around and check. No, it was x equals 3y plus 7, which had no symmetries at all. Now, the more you know in advance, the less work you have to do. I happen to know that that's going to be a line, but if we're just visualizing these things with technology, I really don't have to know in advance what it's going to be. In fact, let's go ahead and turn this graph on. Turn the graph on. Oh, let me recenter the graph, hold on. You can click the home button and it'll recenter the graph. All right, so let's type x equals, and this time I'm gonna zoom out and I want you to watch how the graph changes as I add more to the equation. X equals 3, ooh, that's a vertical line, but I'm still typing. Y, now it's that line, plus, it doesn't know what to do because it's waiting for the number after the plus, 7. Okay, so we get this line down here. Now, for those of you who think you know a lot about math and were thinking, I thought the y-intercept was 7. This equation is not in slope-intercept form. If you don't know what that means, don't worry, you will in the next series of videos. But we were just checking to see if this had y-axis symmetry, x-axis symmetry, or origin symmetry, and the answer is it has none of them. It doesn't have y-axis symmetry because if it did, then this line segment would have to kind of make a V shape. And it doesn't have x-axis symmetry because if it did, then this part above would have to have a mirror image below down here, and it doesn't. Same thing with this part. And it doesn't have origin symmetry because if I turn it upside down, and I'm not sure if this is going to work, but if I turn it upside down, it's not in the same place it used to be. Remember, when it was right side up, it crossed the y-axis down here a little below -2. But when I turn it over, it is no longer crossing at -2. This is weird because it's right side up to me, upside down to y'all, I think. Yeah, anyway. So you don't have to turn your phone or the computer or anything upside down. This doesn't have origin symmetry. If I rotate this line around the origin, it would wind up here. But what about the last one? The last one had all 3 symmetries. So we're going to get out of this equation and check out this last one again, y squared equals x squared plus 2, which seem to have all 3 symmetries. How could it do that? Do you have any idea what the shape's going to be? Well, let's find out. I will tell you that the shape of this graph is a little bit beyond the scope of this course. Not that we can't graph it, but we really wouldn't analyze it much. You would in a pre-calculus class. So y to the second power. Remember, to get a power, you can hit Shift 6 for the caret symbol. Y to the second power equals x. Oh, look at that. It's already sketching a graph, but I'm not done. Hey, look, that graph has x-axis symmetry. Because if I change the y to -y, the negative would cancel. But we're not done. X squared. Wait, what? That's a giant X. There's a reason why. But we're not done. Plus something. What was it? Plus 2. All right, so without the plus 2, it kind of looked like that. Actually, I want to show you one more really nifty thing in Desmos. It's called sliders. Instead of 2, I'm going to put a letter like C. And it doesn't know what the C equals, and it's going to ask me to add a slider. A slider is it's literally something that can slide back and forth that changes the value of the variable. So right now it thinks that the C equals 1.3. But if I click and drag this down to 0, if I can hit 0, there it goes, then it gives us that X shape that we had a minute. But I want that equal to 2, so I'm going to slide it over and make it 2. So right now it thinks the letter C is equal to 2, so it gives us the correct equation that we had on the board. And if you notice, we get this thing. This is called a hyperbola, but again, this is a little bit beyond what we were going to do in this course. I only wanted to show you the graph to illustrate that it has all 3 symmetries. It does have y-axis symmetry because the left half is a mirror image of the right half. It does have x-axis symmetry because the top half is a mirror image of the bottom half. And it does have origin symmetry because if I turn the graph upside down, we'll try this one more time, it's going to look exactly the same as it did before. Again, I don't know if it's actually turning it upside down because I'm rotating my phone, but I think you can see that this has origin symmetry. This thing's clearly not a function that violates the vertical line test. I do want to show you one more cool thing with Desmos. If you have an equation with a variable, that variable is technically called a parameter, and you have a slider set up for it, you can move it back and forth manually and it'll change the graph, but you can also automate it by clicking this arrow and it will change the values, and you can see the impact that changing those values has on that graph. So look in, yeah. So you got these two branches that when they touch, then they split and go in the opposite directions. So pretty cool. All right, so let me turn that off and just put it back on 2. I'm really doing more than just showing you these examples. I'm showing you some of the things that Desmos can do. But you can use Desmos to, sorry, getting some pop-up messages. You can use Desmos to get some really quick graphs of equations, and there's so much more this website does. But for now, we'll just use it as a real quick graphing calculator.